Welcome back. Today, I will cover the module number 9, which is the FHRP concepts of Cisco switching, routing, and wireless essentials lecture series. I would recommend that you watch the lectures from Cisco Introduction to Networks before you dive into this series. I will leave a link to both these lecture series in the description. In this lecture, we will explain how FHRP provides default gateway services in a redundant network. FHRP stands for First Hop Redundancy Protocol, and we will also cover the SHRP, which is the Hot Standby Router Protocol, which is a Cisco proprietary version of SHRP. First Hop Redundancy Protocols. Default gateway limitations. End devices are typically configured with a single default gateway IPv4 address. If the default gateway router interface fails, LAN hosts lose outside LAN connectivity. This occurs even if a redundant router or layer 3 switch that could serve as a default gateway exists. First hop redundancy protocols, FHRPs, are mechanisms that provide alternate default gateways in switch networks where 2 or more routers are connected to the same VLANs. So the primary purpose of FHRP is to provide that alternate default gateways in switch networks where 2 or more routers are connected to the same VLANs. Remember, if you have a router that is connected to a switch and then you have a device at the end, if the router fails, basically, the LAN loses the outside LAN connectivity. The host in the LAN loses the outside network connectivity. So FHRP is like a system where it is creating redundancy or backup in a case that had failure, because if you just connected a bunch of routers together, it's not going to automatically switch it between routers if one of them fails, but the FHRP is allowing us to do that. So that's the primary purpose of SHRP, that you should understand, the mechanism, why we use FHRP. So you should understand that is the primary reason for using FHRP, providing redundancy for default gateways. So let's look at that router redundancy. One way to prevent a single point of failure at the default gateway is to implement a virtual router. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN. By sharing an IP address and MAC address, 2 or more routers can act as a single virtual router. So the IPv4 address of the virtual router is configured as the default gateway for the workstations on a specific IPv4 segment. When frames are sent from host devices to the default gateway, the host uses ARP to resolve the MAC address that is associated with the IPv4 address of the default gateway. The ARP resolution returns the MAC address of the virtual router. So it's not returning the MAC address of any individual routers. It's going to send the MAC address of the virtual router. The frames that are sent to the MAC address of the virtual router can then be physically processed by currently active router within that virtual router group. So basically, bunch of routers are working together as a single router and creating that illusion of a single router by having that virtual router and virtual MAC address and that IP address associated with that virtual interface. A protocol is used to identify 2 or more routers as the devices that are responsible for processing frames that are sent to the MAC or IP address of a single virtual router. Host devices send traffic to the address of the virtual router. The physical router that forwards this traffic is transparent to the host devices. A redundancy protocol provides the mechanism for determining which router should take the active role in forwarding traffic. It also determines when the forwarding role must be taken over by a standby router. The transition from one forwarding router to another is transparent to the end devices. The ability of a network to dynamically recover from a failure of a device acting as a default gateway is known as the first hop redundancy. So these are the key concepts of router redundancy, and these are the fundamentals associated with it that you should understand for your exams and quizzes. Steps for router failover. When the active router fails, the redundancy protocol transitions the standby router to the new active router role as shown in the figure on the right hand side. These are the steps that take place when the active router fails. So on the right hand side, we have the redundancy created in here with these three routers acting as a one single virtual router. And we have a LAN with a few end devices connected, and the virtual router in between the LAN devices and the internet is being used to connect to the internet from the LAN side to the internet. So the standby router stops seeing hello messages from the forwarding router. So if you have a router failure, that's the first thing going to happen. The standby router stops seeing the hello messages from the forwarding router. Then the standby router assumes the role of the forwarding router. So if we have a router here and then this link goes down, and because of those hello messages are not there, the standby router now going to take over. Because the new forwarding router assumes both IPv4 and MAC address of the virtual router, the host devices see no disruption in service. So remember, this entire section that containing these three routers are combined into one virtual interface and one virtual router, right? So what that means is basically these devices down here in the LAN, they don't even know that this router failed. The only thing they know is they have constant network connection to the internet, and they have no idea that it's just been taken over by the standby router. So that's an advantage of that redundancy. So it's very smooth. So there is no disruption in the service for the clients. So if you look at FHRP options, here's a summary of that provided to us by the Cisco in a one single table. For your exams and quizzes, it is very important you understand all of these, in at least this much detail. So even though in this class, we do not go into depth of VRRPs and GLBPs and IRDPs, for example, you still need to understand these do exist and what are the differences and which of these are Cisco proprietary and which of these are international standards. So you should know what they are and how they work in basic sense. So in this slide, that's what exactly the Cisco is trying to get at you. You should be able to understand this concept at least to this degree that's shown in this slide. So let's look at those options quickly. So we have the hot standby redundancy protocol, or HSRP, which is a Cisco proprietary FHRP that is designed to allow for transparent failover of a first hop IPv4 device. SHRP is used in a group of routers for selecting an active device and a standby device. The active device is the device that is used for routing packets. The standby device is the device that take over when the active device fails or when the preset conditions are met. In our next few slides, I will go over the HSRP concepts as we will cover that in this lecture. HSRP for IPv6. This is also a Cisco proprietary FHRP that provides the same functionality of SHRP but in the IPv6 environment. An HSRP IPv6 group has a virtual MAC address derived from the HSRP group member and a virtual IPv6 link local address or LLA derived from the HSRP virtual MAC address. Periodic router advertisement (RAs) which are needed in IPv6 are sent for HSRP virtual IPv6 LLA when the HSRP group is active, and when the group becomes inactive, these RAs stop after a final RA is sent. Virtual Redundancy Protocol version 2 or VRRP v2. This is a non-proprietary election protocol that dynamically assigns responsibility for one or more virtual routers to the VRRP routers on an IPv4 LAN. This allows several routers on a multi-access link to use the same virtual IPv4 address. In a VRRP configuration, one router is selected as the virtual router master, with the other router acting as backup in case the virtual router master fails. I will go over VRRP in a different lecture series, but it is something that you should know exists. VRRP version 3 provides the capability to support IPv4 and IPv6 addresses, and the VRRP v3 works in a multi-vendor environment and is more scalable than the VRRP 2. Again, I will cover VRRP in a different lecture series or a different lecture so that we will go into depth of how they work, and also we will look at the labs associated with that. Gateway Load Balancing Protocol or GLBP is a Cisco proprietary FHRP that protects data traffic from a failed router or circuit like HSRP and VRRP, while also allowing load balancing, also called the load sharing, between a group of redundant routers. So this GLBP is a Cisco proprietary method, but it provides load balancing in addition to the advantages of using FHRP from up here. GLBP for IPv6, basically the IPv6 version of the GIST GLBP, just like the IPv6 version for the HSRP. ICMP Router Discovery Protocol, also known as IRDP, is also a international standard RFC 1256. And it is a legacy FHRP solution, and IRDP allows IPv4 hosts to locate routers that provide IPv4 connectivity to other non-local IP networks. So as I mentioned before, next we will be looking at the HSRP in little bit more depth so that you have a better idea about how that works. So let's look at HSRP. Here is an overview of HSRP. So as I mentioned before, Cisco provide HSRP and HSRP for IPv6 as a way to avoid losing outside network access if your default router fails. HSRP is a Cisco proprietary FHRP that is designed to allow for transparent failover of a first hop IP device. So remember that HSRP is a Cisco proprietary version of FHRP. HSRP ensures high network availability by providing first hop routing redundancy for IP hosts on networks configured with an IP default gateway address. HSRP is used in group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the SHRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. So this is an overview of how HSRP works. HSRP priority and preemption. The role of the active and standby routers is determined during the HSRP election process. By default, the router with the numerically highest IPv4 address is elected as the active router. However, it is always better to control how your network will operate under normal conditions rather than leaving it to the chance. So by default, it will pick the highest, the router with the highest numerically highest IPv4 address as the active router. But you can always configure that whatever the way you would like to have your system be run. HSRP priority can be used to determine the active router. So the router with the highest HSRP priority will become the active router. By default, HSRP priority is set to 100. If the priorities are equal, the router with the numerically highest IPv4 address is then get elected as the active router. So the HSRP priority setting is a way that you can change that active router. To configure a router to be the active router, use the standby priority interface command, and you can use the range of the HSRP priority between 0 to 255 in order to change that standby priority. And on the right hand side, you have a diagram, a network diagram provided to us by Cisco, and it has a virtual router with two routers associated with it, R1 and R2. This R1 become an active router because the system or network administrator have set the active router priority, the standby priority to 150. So as a result of the standby priority sitting at 150, which is higher than the other one which has a priority of 100, this become the active router and this become the standby router because the priority value, the standby priority value is higher on R1 than on R2. By default, after a router becomes the active router, it will remain the active router even if another router comes online with a higher priority. So that's an important concept. By default, in HSRP system, after a router becomes an active router, it will remain the active router even if another router becomes online with a higher HSRP priority. To force a new HSRP election process to take place when a higher priority router comes online, preemption must be enabled using the standby preempt interface command. So if you want your system to always take up on the router with the highest priority, even when the lower priority router has already taken the responsibilities, you have to use the standby preempt in the interface command. The preemption is the ability of an HSRP router to trigger the election process. With preemption enable, a router that comes online with a higher HSRP priority will assume the role of the active router. So if you have the standby preempt configured on this HSRP system, what's going to happen is whichever the router that has a highest priority will take over that virtual interface, because this standby preempt command will ensure that it will gonna trigger the re-election process every single time a router with a higher priority join this group of routers. Preemption only allows a router to become the active router if it has a higher priority. A router enable for preemption with equal priority but a higher IPv4 address will not preempt an active router. So that's another key feature that you should remember on your exam. They might ask you that question on your exam, because I got that question, I remember. So on CCNA and CCNP exam, they will give you a router with equal priorities, but one of the routers is already active and both of them will have standby preempt. So they will ask you that if you add this router to this pool of routers, what's going to happen? does the SHRP gonna have the re-election process done and then gonna get switched between the routers? The answer is no, because even though it has a higher, may have a higher IPv4 address, the new router, the standby preempt command will not re-elect that router as the main router if both of them have the same priority as the one currently in charge of the process, right? So that's a key piece of information. So again, I'm going to repeat that again. Preemption only allows a router to become the active router if it has a higher priority. A router enabled for preemption with equal priority but higher IPv4 address will not preempt as an active router. Remember that, that's a very important. So please note, with the preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process. So if you have a bunch of routers in HSRP pool or HSRP design here, and none of them have the standby preempt set up, if the preemption is disabled everywhere, what's going to happen is whichever the router that comes online first become the active router at that point. So these are the HSRP states and times. So we have HSRP states initial, learn, listen, speak, and standby. So initial is a state that is entered through a configuration change or when an interface first become available. Learn state is when the router has not determined the virtual IP address and has yet to see a hello message from an active router. In this state, the router waits to hear from the active router. The listen state, what's going to happen is the router knows the virtual IP address, but the router is neither the active router nor the standby router. So it listens for hello messages from those routers. The speak state, what's going to happen is the router sends periodic hello messages and actively participate in the election of active and no standby router. So this router is try to be either active or standby by sending out those hello messages. Standby, in state, what's going to happen, the router is the candidate to become the next active router and sends periodic hello messages. For your exams, you should know each of these states and how they are differ from each other. When you go through your lab processes and when you are working on your labs, you will get to learn about these states much more detail, and it will help you get better grades on your lab quizzes as well as lecture quizzes and exams. Again, I will post separate videos on my lab demonstrations onto my YouTube channel later sometimes. For now, just remember these states and what they mean for HSRP and how it is differ from each other. The active and standby HSRP routers send hello packets to HSRP group multicast address every 3 seconds by default. The standby router will become active if it does not receive a hello message from the active router after 10 seconds. You can lower these timer settings to speed up the failover or preemption process. However, to avoid increased CPU usage and unnecessary standby state changes, do not set the hello timer below 1 second or the hello hold timer below 4 seconds, because that might create an issue with the CPU usage of your Cisco device. So that would bring us to the end of this lecture, and I will go over the items that we have covered. We learn FHRP provides alternate default gateways in switch networks where 2 or more routers are connected to the same VLAN. We learn one way to prevent a single point of failure at the default gateway is to implement a virtual router. With a virtual router, you could have multiple routers that can be configured to work together to present the illusion of a single router to the host on the LAN. This is done by creating that virtual router. When the active router fails, the redundancy protocol transitions the standby router to the active router role. These are the steps that takes place when the active router fails. The standby router stops seeing hello messages from the forwarding router. The standby router assumes the role of the forwarding router because standby router realized that the forwarding router has failed. Because the new forwarding router assumes both IPv4 and MAC address of the virtual router, the host device see no disruption in the service because its host devices only see the virtual IPv4 and the MAC address information. So all of these things happening inside that the FHRP process, so the end devices don't see a difference. The FHRP used in production environment largely depends on equipment and the needs of the network. These are the options that are available for HSRP that include the FHRP and FHRP for IPv6, VRRP version 2 and VRRP version 3, which I will cover in a separate lecture. GLBP and GLBP IPv6 again, which I will cover in a separate lecture that is not associated with these lecture series sometimes. IRDP is also another option for FHRP implementation. HSRP is a Cisco proprietary FHRP designed to allow for transparent failover of a first hop IP device. HSRP is used in a group of routers for selecting an active device and a standby device. We learn in a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and quickly assume the packet forwarding responsibility if the active router fails. So the preconditions, remember the preemption, for example, those are the preconditions that they are discussing up here. So the router with the highest HSRP priority will become the active router. Preemption is the ability of an HSRP router to trigger the election process. With preemption enable, a router that becomes online with a higher HSRP priority will assume the role of the active router. So the HSRP states include the initial, learn, listen, speak, and standby. So those are the key concepts that we covered in this lecture. And that pretty much covered everything we went over today. There is a packet tracer file called HSRP configuration guide. If you have access to this file, please go ahead and do them. If you do not have access to this file, I will find a copy and post to my sanuja.com website, and I will try to leave a link in the description of this video so that you can go ahead and download it. And that is the end of this module. Please thumbs up this video and subscribe to my channel. If you have any questions, concerns regarding any of the topics that we have covered, please don't hesitate to reach out to me. Make sure you go over all of these slides and the concepts before you take your exams or quizzes. And good luck with your exams and have a nice day.